Good afternoon, or good morning, or evening to those of you in different time zones, and a warm welcome to you all. My name's Elena Marie Bassett, and I'm the Business Manager at BIC. We're delighted to have so many of you attending this, our first ever Green BIC Brunch session, which will focus on the materials used to produce books within our industry. This session is the first in a brand new series of Green BIC Brunches, which we've specifically created to explore key areas of the book industry supply chain that can and do impact upon our planet's environmental health. Each Green BIC Brunch will be dedicated to one key area of the supply chain, whilst the series as a whole is intended to join the book industry together in one place, exploring and inspiring change in response to environmental challenges. All part of BIC's Green Promise. We'll be tweeting about this event using the hashtag Green BIC Brunch, so do feel free to join in. Here is the agenda for this session. You'll note that we have 4 speakers lined up for you, including Stephen Holman from Holman Paper, Lisa Ferratro from CPI Books, Alexis Tonneau from KURZ, and Jamie Beale from Graphic Image Films. You'll also note that there is a dedicated 10-minute time slot allocated at the end of this event for questions. Before we kick off the event, I do have a little housekeeping. Whilst this is an informal online session and asking questions is therefore actively encouraged, we've taken the liberty of muting you all to ensure that the sound quality for this event is the best that it can be. This is especially important because this event, as you all know, is being recorded. If you have a question to ask our speakers during the dedicated Q&A session, you will either need to type your question in the chat box provided or need to unmute yourself in order to speak. Please do let us know your name and the organisation for which you work prior to asking your question. If you would then be so kind as to remute yourself once you've asked your question, we would appreciate it. For those of you who are not speaking and do not have a question to put to our speakers, please do remain muted throughout the event. Thank you in advance for your help with this. This event is brought to you live by Book Industry Communication Limited. So who are we? For those of you who don't know already, BIC is a UK-based not-for-profit members organisation at the heart of the book industry, creating standards, best practice and resources that form part of the DNA of your supply chains, helping your organisations become more efficient, save money, become less wasteful and ultimately become greener. At the cornerstone of the book industry, we hold a unique position of trust, facilitating UK and international industry-wide collaboration to reach agreement on dependable standards and best practice in the supply chain. It is in the supply chain that significant changes can be made by the book industry to lower our carbon footprint and improve our green credentials. BIC, being the long-established dedicated supply chain organisation, has the environment naturally high on our strategic priorities for 2020 and beyond. We're committed to championing the green agenda and providing leadership to provide organisations with the tools and resources to help them make their supply chains greener and more sustainable. To help with this mission, we've recently launched the BIC Green Hub, our new resource for the book industry, where we will share information on how we as an industry can be greener and to showcase what BIC is doing to help organisations achieve this. Do take a look, the link is shown on your screens currently. So how do we operate? We have 4 strategic committees in place, all of which contribute to BIC's overall green agenda, as the best practice and standards that they create and promote give guidance on reducing wasteful processes and improving efficiencies, all of which is critical to reducing the environmental impact of organisations. All our committees report to the BIC board, are run by representatives from BIC member organisations, and help to determine and progress the work that we do at BIC for and on behalf of the industry. We also have a number of projects and review groups which are overseen by these committees. Events are key to BIC's reach within the book industry, and we host a number throughout each year, including our BIC Breakfast, BIC Brunch, and now our brand new Green BIC Brunch sessions, various networking events throughout the year, and our annual seminar at London Book Fair. Our industry recognised training is also at the heart of BIC's activities, as we strongly believe that successful businesses start with people. We welcome your engagement and are on all of the usual social media platforms, so do get involved in any way that you can. So what is a Green BIC Brunch? Our Green BIC Brunch sessions are a brand new series of short online events that focus on a particular supply chain topic or issue impacting the environment. They've been set up to provide the book industry with a regular forum for exploring and inspiring change in response to environmental challenges. Please do make the most of this event by asking any questions that you might have. As I mentioned earlier, whilst we welcome questions at any point throughout this event, please be aware that there is a dedicated Q&A session at the end of the webinar. Further information about all of our forthcoming BIC Brunch and Green BIC Brunch sessions can be found on our website via the addresses currently shown on your screens. Or, if you're only interested in Green BIC Brunch sessions, via our brand new Green Hub. We'll be creating a series of Green BIC tips which will be based on these webinars and will be made available on our website shortly after each session. I'll now pass you over to our first speaker, Stephen Holman, Head of Technical Support at Holman Paper. Over to you, Stephen.
Hello, can everybody hear me now?
We can. Lovely, thank you.
That's worked. There we go. Right, let me just make this. No, hang on a sec. I'm just making sure I'm sharing the correct screen. Can everyone see the title page?
We definitely can. Thank you.
Brilliant. Brilliant. Yeah, I'd just like to go through a shorter version of our life cycle assessment that we've produced for our papers. Holman don't use recycled paper, we create it, we grow it. Basically, we only use virgin fibers in our papers. Recycled paper fibers can only be used 5 to 7 times before they get too short and worn out, and they can't be used for the products that we produce. We lose bulk, we lose brightness, and it's an issue. As it stands across Europe, 72% of paper and paperboard is recycled. There's not a lot of chance for growth for this, so the chain needs topping up with it needs a supply of fresh fiber to keep the system going. And there are some papers that some products that physically can't be recycled. Tissue, wallpaper, and also more pertinent for people in this group, books that are kept for a long time, which we all want people to do. So at the moment, about 22% of paper cannot be recovered. In our Swedish mills, which we have 2 of them, we use mechanical pulp process, which allows us to convert about 95% of the pulpwood we receive into paper. The remaining percentage is used as biofuel. This is a life cycle assessment. It's an accepted method for studying the environmental performance of our paper, which is what we wanted. We wanted to know the full environmental impact throughout the paper's entire life cycle, production and so forth. Obviously, we did it because of the there's negative perception of a fresh fibre in the market and in society at large. We particularly had issues with, not issues, we came up against obstacles with the Blau Engel organization in Germany. So we wanted to have a positive argument for fresh fibre. We asked the Swedish environmental research to do. It was done at full ISO standards, which includes third-party reviews, because we want it to be accurate. What we've taken is 1 kilo of fresh fibre produced paper and 1 kilo of 100% recyclable paper, and used a circular formula footprint to follow it round. So basically, this is the steps that we used. So and expect again about the recycling. Germany, because they recycle about 85% of their products. What we wanted to do, the circular formula footprint is use so that recycled material doesn't come for free. The material has to carry some environmental impact from its earlier life, an upstream impact. The impacts and benefits of recycling should be distributed between the producer of the recycled material, as well as the input, as well as the product being recycled. Sorry. So again, so basically, we found that the climate impact is lower from paper produced with fresh fibres. As you can see from this one, we've produced fresh fibre paper produces less CO2. The eutrophication potential, which is the amount of chemicals that can get into soil and water sources. If it gets into water sources, it reduces oxygen levels, which can then affect plant life, fish, animal life in the water. And then acidification potential, which is acid rain, more commonly known as. So what I'd like everyone to take away from this is that the former life of material has to be included in any impact that we look at. Papers from our Swedish mills do have a lower environmental impact compared to recycled paper from Germany on, CO2, on eutrophication, acidification. We do have a lower impact, and also it needs to be taken into consideration that in our Swedish mills, our electricity supply has a lower environmental impact as well, which is all, and that our raw material is from a sustainably managed forest, which is, our forest is growing. It grows every year. Our owner loves it. He's growing money. So that's always a positive, that's something we need to take into consideration. And also this report doesn't allow for the positive climate effects from the actual growing of the forest, which is, obviously everyone knows about the CO2 emissions, so that's good. So basically fresh fibre paper should be produced where the electricity mix has a low environmental impact and where the raw materials come from a sustainably managed forest, which is what we believe we do. And I've spoken very quickly, so I do apologise, but that is the end of my presentation.
Thanks, Stephen. I'm going to take the screen back from you.
Yep, that's fine. If you take it back, then I don't have to. And then I shall mute.
So our next presenter for this session is Lisa Ferratro, the Customer Service Director and Director of Environment and Sustainability at CPI Books. Over to you, Lisa.
Thank you. I'm just going to share my presentation. Right. So materials matter. What I'm going to discuss today are some elements of what materials are actually going into the books that we produce. So what are the weights of the books that we produce, and what are the percentages of the different materials within that book? Just to try and put some context around all of the elements that Stephen discussed, and also further on in this presentation from graphic image around laminates and also around foils, just to put it into context of the whole book and elements in it. I'll then go on to talk about the waste streams of those books and where they go within the recycling element and what they become. I may have discussed some of this on the previous presentation that I did, so I'm hoping I don't rehash information for you. And then the main element of what I'm going to bring in is really what the glue is, what those materials are, what they're made up of, and the types of glue that we actually can produce books with within CPI. And then lastly, new materials, how we're finding what they're like on the market and how we introduce those to publishers, just to give you ideas really for the future, and how it is that we stay close to our supply chain to make sure we bring you all the new ideas and products that come from our suppliers. So firstly, what makes up a book? I've picked an average pagination book of a royal paste to give you the volume of that book. So this particular book weighs around 500 grams, and 81% of that is made up of the paper within that book. So that's the text paper, the woodland cover, and also the jacket element and end papers. Then 16.5% of that book is obviously made up of the greyboard, the hollows, and the crepe that make up that book. So again, very large percentages we're talking really, which is why a book is easy in theory to recycle, because so much of that is known matter. The laminate on this particular book is only 0.6%. So obviously the higher pagination book, the laminate is even a lower percentage. Obviously on a smaller book, it's slightly higher. It's a very small element of the total of the book. The foil, even less so, just 0.04% based on an average amount of foil across that book based on the weight of foil. And then lastly, the ink is just over 1% and the glue just over 1%. So this just gives you an idea really and puts into context the materials that are in the book and what they actually form as the total amount. So obviously the main elements are always going to be the paper and the greyboard element on the case book. So where do these products go and how do they get recycled? So books and mixed papers. So mixed papers are when you have something on your paper other than just ink. So this is where we have a laminate, we'll have a foil. Those elements are separated. It's all about how you separate at your printers. And the more separations you can do, the more value there is in each of those products, because they can go direct to the recycling company. So books and mixed papers actually get recycled into corrugated packaging. They're classed as a clean product. They understand what's in them. They know what they're made up of. And actually they're quite easy to recycle within the whole process and hold a value within the market. Section waste, this is just something with print on it only, and binders trim. So this is the very small amounts that we take off on the binder. They get actually recycled into newsprint for newspapers and provide some pulp back into the industry. And then lastly, sorted office waste. So this is your white copier waste or waste from offices. Gets recycled into hygiene products and goes off to tissue plants. So again, this is how we recycle and keep the certain waste streams separated within each process within the factories. And then lastly, unprinting waste. So obviously this is the most expensive form of waste within our process, because obviously we want to print on everything. But there are elements that we can't print down to. So those sheets or those reels and cores actually are white waste, and they also get recycled into newsprint. So the product they end up with isn't different, but the value that you get for an unprinted waste versus book waste is higher. So there's a commercial element to all of these. Currently in the market is very low because there's a lot of recycled products on the market. So it's also trying to get the best value you can, and that's really by sorting as much as possible with the printers. So this is just to show you what your printers can have. So we actually have this across all of our sites. So this shows that each site within CPI is zero waste direct to landfill for paper elements. So this is just showing they're all going off. You get certified each year by your waste supplier. And we have different ones for each type of product that we have within our waste system. So this is just an example of what you can get from your suppliers. So for non-paper products, it's slightly different. Again, it's all about sorting. I think in an ideal environment, you would have thousands of bins around a factory, but that's not overly possible. So really, it's about how you can separate as efficiently as possible. So shrink wrap, for example, gets recycled into injection molded plastics. So they do get recycled within the process, and they make things like drain pipes. Wooden pallets are the broken ones that sometimes obviously we recirculate as much as possible wooden pallets from warehouses back through to supply chain. But when they are recycled, they get broken down and made into chipboard or fiberboard, and also used on foot on golf courses, just an example. Plate developer, this gets collected and it's recycled using biodigestion. So this is where bugs destroy the hazardous liquid within the element and create a waste element. The liquid is further processed before returning to the relevant watercourse. The majority of the waste, 95% of it, actually goes back to be recycled as within the watercourse. The rest of it actually goes and is created into an ash and it is then recycled within that process. And aluminium plates, probably the most expensive product that most printers use. They're actually recycled either back into aluminium plates, so very much a circular industry, or used within the car industry. So it's all about finding resources for recycling all elements from your site to make sure that you're being as efficient and also commercial as possible. So now on to glues. So these are the paperback glue types that we run within CPI, and these are quite well known within the industry. So PUR obviously is the nearest alternative to stone product and very much been taken on board at most printers, particularly around coated materials, so on the heavier colour titles, so not so much within paperback mass market production, but very much within the colour market. It is an efficient type of product. Sorry, I just need to stop my phone. It's very much the polyurethane is, there are some concerns around health and safety. So you need to, there are certain things that you need to put in place around the health and safety of running PUR. It's a different type of glue to mass market manufacture. So therefore, on this type of product, you do need to bear that in mind, but obviously for the production of a paperback within colour, it's particularly efficient. The alternative to it is polyolefin glue, which is PO glue. This runs on a very similar system to a standard glue. Doesn't offer quite the same amount of page pull that you will get on a PUR. Is a very good alternative, and is something we've definitely worked very hard on for our coated materials, particularly off of our quantum presses. EVA, so this is the type of glue that you will see in most mass market and case books, mono books within the UK. This is a hot melt glue that we run. And lastly, PSA, which is the side glue, which is a rubber-based glue for all products. All of these actually are derived from petrochemical sources, so they're a byproduct of the petroleum industry. Natural materials that are used are not from animal-derived materials, so they can be classified as vegan. And I know this often comes up as questions from publishers when they're producing certain books. All of these technologies are used to minimise the fibre contamination. So this is all about how you then put them into a recycled process. So it's how you do the repulping, that when a book is recycled, those adhesives can be screened out, and then you're able to separate the elements and go through a recycling process of either a book or elements of a book. So on to hardbacks. It's extremely similar. So all of the book blocks are exactly the same as a paperback. The only difference you have on them is obviously an end paper and crepe. The difference that you do get is on case making and backlining, mainly within the UK and within Europe, we use a gelatin-based glue. The gelatin-based glue obviously means that it's not a vegan product, and this is mainly used because we're actually, these applications, they're designed because they need to have a high tack level for making those cases and casing in the materials. So historically, the machines that are designed have been to use the gelatin-based glues. But one of our CPI sites, we do have machinery that does have the ability to use a non-gelatin-based glue. It isn't simple, but it's a possibility. So you can have a vegan product, but obviously the majority of hardback books wouldn't be classified as vegan. And lastly, onto the new materials. So obviously, most of you will know that Holman did a lot of work on providing lower grammage papers with higher microns, giving both savings within the industry and also an efficient use of paper and tonnage. What we're also seeing is we've seen recycled wibbling come on stream this year. So that also is something extra that's been brought into the market. PO glue is something we've been working on for the last 2 years with our supplier. And again, something as an alternative to PUR, which has less health and safety issues. And then what we are seeing come onto the market very much so at the moment is the antibacterial coatings or the antibacterial coatings on laminates. This is something that is of some interest, obviously, with the current situation around COVID-19. But obviously there are definite options for it, but it's about how we engage with suppliers in making sure that we give all of the information out to publishers so that you can, you're informed and you know the choices that you have available. So that's very much where we as a supplier work with our suppliers ourselves very closely to make sure that we're either beta testing, testing new elements so that we can actually bring it to our publishers as quickly as possible to market and make sure we've done all those tests before people hear about them. I'm going to pass back to Elena now.
Thank you. I do actually have a question from one of our attendees for you, Lisa, if you don't mind answering it at the moment. Do you also buy products made from recycled materials, and are there recycled alternatives for things like aluminium plate?
So the aluminium is already a recycled product. So within those products, a lot of what we're getting is already recycled, so they're not fresh aluminium. So that's what we do is we'll take the material and then we'll have a recycled stream for it. We don't specifically go and buy recycled elements, mainly due to the fact that we have a recycled part of what we're sending out into the waste stream and not bringing back in. What we do is work with our suppliers to make sure we've got both the waste stream and our particular focus this year is to engage with our suppliers around what their own environmental accreditations are, how it is, what type of energy they're using. So the same questions we're being asked by suppliers, by our publishers, we're actually asking about our supply chain, and we're hoping to use that within some of the information that we put out this year.
Makes a lot of sense. Thank you. The next up is Alexis Tonno, Sustainability Project Manager at KURZ. And I will pass the screen across to you now, Alexis.
Everyone, can you hear me?
Yes, we can. Thank you.
Perfect. Thank you. So my topic, I will talk about foil and especially hot stamping. So I think the question today is everyone is asking is KURZ foil recyclable? So many people ask us this question, and you probably already ask yourself this one, and it's not easy to answer. There is several aspects behind it. There is first the production process and the customer process. So what is happening at our process? So there is several important points. So first, we don't use any water to produce foil. So we don't reject any wastewater. We are using 100% electrical energy from sustainable sources in Germany. And we also produce with the wireless printing machine industry, so to be more efficient and also to lower our CO2 per square meter. And we are using our solvent twice, which means that once the lacquer we use during the production, we use it again to generate energy and to dry our foil in our facilities. We are also manufacturing locally, so we have several plants worldwide. We have a plant in the USA for America, one in Germany for the European market, and one in China and Malaysia for Asia. So our goal is to have less impact possible with the transport around the world and to be local, so to a global company and for local market. and we try to minimize our CO2 impact with short transportation. So what are the aspects regarding the sustainable aspect for the application process? So when you hot stamp a book, for example, so it's a dry process, so there is no coating involved. You don't need heavy water. There is no odor nuisance, no exhaust air. There is no residue, no lacquers, and the only waste is the stamped carrier, the PET carrier, and it's also an emission-free process. So both process, manufacturing process and the customer process are producing waste, so the PET waste. So we receive a lot of questions regarding this PET, if it's recyclable or not. I think it's one of the first question in the is called foil recyclable. So it's a big topic. We are working on it for many years. So first, we don't put any foil to landfill. We are part of the No Foil to Landfill initiative in the UK. And every foil, which is every waste generated during our production, is used to produce energy out of waste, so waste to energy. So it's not directly recyclable, recycling, but we wanted to do it, and we are going to do it. So there is several things possible with the PET carrier. So first, there is the mechanical recycling, so just reprocessing the PET waste. Then there is chemical recycling, depolymerization. There is then chemical recycling pyrolysis. It's another kind of chemical recycling. And the last one is incineration, so waste to energy. So with PET, there is only three possible recycling methodology. And at KURZ, we are focusing on the two first, mechanical recycling and chemical recycling. And our goal is to present a project in the next week, months about mechanical recycling. So you will hear about it very soon. Then the next aspect is the end product. So basically the book, and there is several aspects behind it. So first, it's not a foil. We are always talking about foil, hot stamping foil or cold foiling, but it's not a foil, it's just a dry printing. We're just transferring a few layers of coating on the product. It's no laminate. That's something I think interesting for many people, that on the end product there is no plastic. We're just removing the PET from the packaging or from the book, and you just have a few coating layers on the product. So there is several layers on our products. There is first the carrier, which will be removed. Then there is a release layer to help separate the other layers. Then there is a protective layer, a top coat, which will define the shade and the protection you need. And then there is a metallization. And the last layer is the adhesive layer, so which will depend on the quality you want to achieve on the substrate also. So the total thickness from all of the transferred layers 1.5 to 3 microns, and the aluminium layers transferred on the product is 0.02 microns. So it's a very small amount of aluminium. Compare, for example, to a beverage carton, which has several paper, plastic, and aluminium layers. The aluminium layers in a beverage carton is 6 microns. With metallic ink or metallized paper, you can achieve 0.2, 0.1 microns on aluminium. And with hot stamping, you achieve 0.02 microns. So what is it exactly? So it's not a foil, it's not lamination, it's a transfer, like I already said. There is no PET on the product. There is no hazardous ingredients also on the product, and the aluminum quantity is minimum. So the question behind is the end product, the book or the packaging, recyclable? And we did a lot of tests to see when these products become a waste, what is really happening, and what is happening in the recycling facilities, in sorting facilities. So basically there is several aspects. First, the design for recycling, the production process, how we can improve and be sure that a specific product will be well designed to be recycled, how it will be collected and sorted. So we went to several facilities and also to suppliers of sorting systems, and we have been tested a lot of samples, paper-based cardboard packaging, magazines, but also plastic packaging with metallic effect on it to see how it can be accepted and recognized, how the facilities will sort the product. And we also worked on the dinking. So basically, when you sort the product, there is several kind of paper waste. There is paper will be just repulp, like paperboard, and there is also paper magazines will be de-inked, where we will remove so the glue, the adhesives, the ink, and also the embellishment, the old stamping. So we worked on several steps to see how can we claim that it is recyclable. We started with a certificate and test for the technical aspect, and I will show you a few examples afterward. Then we made some tests in sorting facilities, and we are also doing some tests with paper recyclers to see at a bigger scale how can a few tons of paper with hot stamping can be recycled. So for the technically recycled, we worked with INGEDE. So INGEDE is the International Association of the Inking Industry, where we tested several hot stamping and cold foiling qualities, and they give us almost always the best score possible. So this association is well known in the paper industry, and they say that the product is good de-inkable when there is between 71 and 100 points, and we receive 96, 97 and 100 points for all the products we have tested so far. We also worked with the compostability. So I'm not I don't think that compostable is a solution for paper because it can be recycled, but many customers ask us, can my product with hot stamping can also be compostable? So far we've got one certificate for one of our quality MTS 220, which means that it can be used as a safe additive and in the industrial composting process, and up to 1% of the total mass. So with the weight of the paper included, you can achieve the compostability and claim the product compostable. So the quick presentation. So what we have learned with all those tests is that paperboard are 100% recyclable and dinkable when they are decorated with hot stamping or cold foiling, and this also can be compostable. That's a PET stains industry, and it can be easy to recycle in several ways. That was from my side.
Lovely, thank you very much, Alexis. I'm going to take the screen back from you.
Please.
Thank you. So our final presentation of the day comes from Jamie Beale, Quality Assurance Technical Manager at Graphic Image Films. Over to you, Jamie.
Good afternoon, it's Jamie here. Hi, I hope you can all hear me.
We can.
Yeah, let me just bring up the PowerPoint. Hope you can all see that. Okay, so we'll just go through that. Just a quick background on who we are. Now, what I wanted to talk to you about today was just a bit of background on the manufacture of BOPP lamination films, what types are available, the recyclability, environmentally friendly options, and the circular economy. So if we just, I don't want to bore you too much, so if we just go with the brief on the manufacturing process. So for the graphic arts industry, the lamination films are made with BOPP films. So BOPP stands for biaxially orientated polypropylene. This is an oil-based product which is derived from the oil refining industry. And I'll just show you quickly some slides of how the film is made. So here we can see the tenter frame process. So basically the extrusion resin, PP resin granules are extruded with a blend of additives, and then they're stretched, so machine direction and transverse direction to create the film. So by doing this process, basically you increase the strength and clarity of the film. After the extrusion process, the film is wound into prime jumbos, ready for coating, conversion, that kind of process. So here's another slide with the acetate film extrusion. Acetate is one of the green films available. I'll talk about that briefly later. Just a couple of slides with the processing. Okay, so after they've been extruded, they then get either straight to a conversion, or they can be coated with maybe soft touch or anti-scratch. If it's a thermal adhesive, then an EVA is coated onto there, and then the film is converted into reels ready for going out to end users. Just a quick advert here. This is the film's actually available at the moment to us. It is ever changing, but as you can see, there's only a few eco names down on there, so we'll talk about that as well. Okay, just very quickly, there's two different types of film. We call it wet and thermal. The terminology explains that quite clearly, but basically the wet film is just the base film. The thermal already has an EVA extruded onto it, so the glue is just heated up on the laminator, and it's processed that way. It's a quicker, easy, cheaper way to do it. Okay, so on to recyclability. So polypropylene is an easily recyclable plastic, especially during the manufacturing conversion processing stage. Whilst only a small percentage of reclaim is put back into the manufacturing of the film, the remainder is easily recycled externally. The reason why they don't put a lot of reclaim back in is for clarity reasons. Now, with recyclability, when you're laminating, you're making a composite product. So ideally, the substrates will go back to the paper mill for recycling, where the individual elements are filtered and separated from each other. The pulp obviously goes back into the paper making process. Generally speaking, though, the filtered elements, i.e. the film and inks, will generally go for incineration down the waste to energy waste stream or sent to landfill. Now, it is worth noting as well, the identification for individual plastics at this stage can be very challenging indeed. Now, we're continuously working with the manufacturing partners to sort greener alternatives. Now, in the market for the last 10 years, we've been selling an oxide biodegradable polypropylene. Now, this sort of it's a technology that's been around for many, many years. Basically, it has an additive put in there that works as an accelerant. When the film's exposed to high temperature UV light, basically the additive kicks in and the plastic polymers fragment down. The molecular structure of the film changes, and then it's ready for sort of microbial biodegradation. But unfortunately, the European Commission, they've been anti this for some time. So what's happened is that they've eventually decided now that by 2021, this technology in the EU will be banned. So it's something that we can't really look at past this year anymore. Another green product that is available is cellulose acetate. Now, cellulose acetate is wood pulp based. It does not derive from oil, therefore it's not classified as a plastic product. And as you can see, it's accredited with being biodegradable, home compostable, industrial compostable. It's only available in the wet grade at the moment. The thermal is in progress. It's still in R&D really, because of the biodegradable adhesive needs to be tweaked, shall we say. Now also there's a PLA film, polylactic acid. Now this derives from vegetable resources. Again, it's not classified as a plastic product. It's only available in a wet grade because the melting point of that film is very, very low. So fortunately, you would, with the normal EVA adhesive, you would melt the film before you would activate the adhesive. Now another coming soon, shall we say, is PCR. So later this year, we'll be bringing a film in which is post-consumer recycled. So it's going to be made with 50% post-consumer recycled PP, and it will be available in most grades. So soft touch, anti-scratch, gloss, matte, the usual one. So it will be something certainly worth looking at. And again, it continues our sort of aim really towards a circular economy where, you know, you produce a film, but it doesn't have a start, it doesn't have an end to its life. Now, another option also, which has been around for a while, is there are some thinner films. So by reducing the thickness of the PP, the polypropylene, you're utilizing less plastic in the lamination side. Although, as Lisa pointed out earlier, that I think it was 0.6% of makeup of the book anyway. So it is a very small percentage that is used. I'll just show you some quick pictures, example of some paper processing. So this is from a processing plant. And then the future, circular economy, which we're all aiming to achieve. And I think that's probably me. Back to you.
Many thanks. I'm just going to take the screen back from you now.
Yep.
So we now have a little time for questions, and I'd like to open the floor to our attendees. If you have a question, please either type your question into the chat box provided or unmute yourself in order to speak, and let us know who you are, the organisation you work for, and who your question is intended for, if not all of our speakers. I will say that we've already received a few questions, so I'm just going to run through those now. So Stephen, I've got two for you, and Jamie, I have one for you at present, but there may very well be more by the time we've got through those. So the first one, Stephen, was for you. How do you come to the figure of 50% of a recycled paper's previous life? It seems that the key figure that leads to your conclusion that fresh fibre is better for the environment.
Yeah, that figure comes from it's the default standard when using the circular footprint formula. The formula also considers the fact that fibre is in declining quality as it moves down, the more it's recycled. So in Germany, about 85% of the fibre can be reused. So accordingly, in our study, the 42.5% of the environmental impact of its former life is transferred to the recycled production. Hope that answers the question.
It does. Jeff, if you have any further requests in terms of information, then do just speak up by unmuting yourself. So Stephen, the next question that we had was, what do you suggest we do with the old paper if not recycle and reuse it? I think that's in relation to the fact that you were talking about new fibres being better for recycling paper.
I mean, obviously, we still need to recycle. We're not, Holman as a company out saying don't recycle. What we're saying is that the fibres can only be recycled so many times. You know, I mean, for book paper, bulk and brightness, keeping that as a constant is really, really important. And the more recycled fibres you get, the more difficult that becomes, and the problems. You can't guarantee you can't split the fibres to sort of papers that have been recycled once or recycled 4 times. You can't do that. So what we're not saying don't recycle, we're just saying is that recycling isn't a closed loop. You can't just recycle forever.
Okay, that makes a lot of sense. Thank you for clarifying that. So Jamie, your first question, we actually now have 2 for you. The first of which is, do you know on what grounds the PP with additive has been banned?
On what grounds? Yeah, it's basically they've been arguing for many, many years. It's to do with microplastics. So what it is that when any plastic breaks down, which inevitably it will do, unfortunately, normal plastic, conventional plastic, in waste in the environment will just degrade very, very slowly, 50 years plus or so, or even longer. But it will, the UV lights, it will fragment it down. So it will all end up inevitably, if it's not disposed of correctly, into fragments, particles. Now, what this additive does is it fragments down very quickly, but it does change the molecular structure. So the additive manufacturer claims that they don't become microplastics. However, the EU Commission, they've been doing studies for many, many years and have decided that now that they wish to ban it, and they think it is a microplastic still. So although there's still some debate in it, countries like Saudi Arabia insist that all certain plastics in certain industries all have the oxo additive in there. So it depends on the country, but that's what the EU stance is. But it's to do with microplastics. So with microplastics, they're worried, they're very concerned because these are tiny little tiny particles. So they're worried that it could end up in the food chain. So with animals eating it, and obviously then we eat the animals, and then it sort of goes round and round that way. So we're eating plastic in that sense. Although you could argue as well that any clothes that are made from polyester, for instance, any fibers, each time you put on or take off a garment, then particles are in the air, and we breathe those particles in. So you could argue forever on many products.
Indeed.
I hope that maybe that's for a different day, that one.
Yes, maybe not to cover right now.
No.
So we have another question as well for you, Jamie. How durable are thinner films? Okay,
they are durable. It's more the processing. So the thinner you go down to producing PP. So for traditional laminate films, there'll be anything between like a base film. It'll be like a 13 micron film. And then an EVA might be applied if it's a thermal product. By going down to sort of 8-10 microns, obviously you are reducing the PP weight, and at that there is a limit to how thin you can go, because thinner films are very hard to process. So they are prone to creasing a lot more. They can be slightly harder to run sometimes, but it's getting a good even thickness of film across the extrusion, really. But they are very durable. I mean, they're not, once laminated, there isn't an issue with that anyway, certainly.
Okay, many thanks for that.
Okay.
So we have got one more question that I'm aware of at present, and Stephen, I believe it's for you. We have been asked, if recycled paper can be used up to 7 times, how is the CO2 emissions calculated? Is it a cumulative calculation summing up the CO2 emission accumulated every time it's been recycled? For example, if it's been recycled up to 5 times, what is the corresponding CO2 emission based on? Or is it based on the last recycling cycle only, or does it take into account the 5 previous cycles too and sums it up all together? Sorry, that's quite a long question.
Yeah, it's a question I don't have the answer to be perfectly honest. I can find out and I can send it later on, but that's not something I've got to hand. It's the full document is a 90-page document, so I'm frantically trying to go through it now on my other screen, but I can't find that at the moment. But I can do, and I can send it in. I'll send it in as soon as I can.
Okay, thank you. I'll circulate that to everyone that's been in attendance today so that they will know for their reference as well. The second part of that question was also, is the CO2 emission of a recycled paper taking into account the CO2 emission of the virgin fibre paper percentage input in it?
At the risk of sounding very political, I'm going to go back to my previous answer.
Yeah.
I don't have that to hand at the time.
Okay.
So I do apologise, but
no, not at all. Don't worry. I just didn't want to miss the other half of the question, and it might have been something that you could have answered. So, so apologies putting you on the spot there.
No, it's fine.
So I have a question now for Lisa. You mentioned a line that prints HBs with a vegan glue. Is there a reason that this isn't used more widely? So HBs being hardbacks, sorry.
Oh, okay. So it's really down to technology of the machines that you use for the case making and casing in. So certain machines can only run certain glue types in the way that they create and the way that the glue runs into the machine. So certain machines will only run a petrochemical glue, and certain machines will run an animal gelatin glue. So it's more to do with the machinery that you have in plant, and you can't really convert them. By the time you convert them, you might as well buy a new one, and the new products on the market all are around the gelatin-based glues.
Would you say that's becoming more of a decision for printers these days?
I think it's about what's available. So the problem is, I think for most publishers, is if you want to go down the vegan route and have all of your books being produced vegan, can you do that in the market when you're producing books worldwide? So therefore, if you do that, can everybody fall in line with that? And if they can't, do you want to put on a book that this one's vegan, and then there's a question mark over the book that you may have published last year that doesn't have that? It's just a very difficult. And is vegan better? Not necessarily from a food point of view. It's more around, you know, is the process of creating products where we could be using them for different things, is that the right thing? Is petrochemical better than gelatin? Yeah, they're not easy answerable questions. So I think it's more around what you're publishing. Do you need to say something about that particular book and the way in which it's produced?
Okay, thank you very much. So we do have another few minutes if there are any other questions that any of our attendees have. You can feel free to unmute yourself as well. Don't be shy. You can speak directly to our speakers.
Just sorry, Steve from Holman. I think I may have found an answer to how the CO2 is worked out. The official wording, I'm reading it as I do it, is due to lack of reliable data for cascade recycling, i.e. multiple recycling loops, the study uses the first loop of the recycled fibre in the calculations.
Okay, many thanks for that. That's very interesting. I'm going to presume that we haven't got any more questions, which is absolutely fine. But if any of our attendees do have anything that they suddenly wish that they had asked our speakers, do feel free to email me, and I can always pass that question on to our speakers and pass their answer back to you. So I'd like to take this opportunity now to say a massive thank you to all of our speakers on behalf of everyone in attendance. Thank you, Lisa, Stephen, Alexis, and Jamie for your fantastic presentations. To you, our attendees, I'd like to say thank you for joining us for this first of many Green BIC Brunch sessions, and please do stay in touch. You can find out more about BIC and the work that we do via the BIC website at www.bic.org.uk. If you're keen to stay up to date with our green work and events, do check in with the BIC Green Hub, and do feel free to join our dedicated green mailing list. If you work for a non-member organisation and you'd like to find more out about BIC and the benefits of joining us, then please do get in touch as well. We'll make the presentation slideshow for this event available on our website shortly, and a recording of the whole webinar will be posted to the BIC YouTube channel soon. We hope to see you at another BIC event in the near future, but in the meantime, please do take care. Thank you for attending.
Thank you very much.